Now next we'll come to positional isomerism. We finished chain isomerism. Now positional isomerism. See, from the name itself many things we can guess. Positional means what? The position of the double bond, triple bond and the functional group will differ in two or more compounds. The position of the double bond, triple bond or the functional group. That's it. This much only. It can be double bond, it can be triple bond, it can be functional group. When it is going to differ, alright, in two or more compounds, they are known as what? Positional isomerism. Isomers, and the phenomena is called as positional isomerism. So what? How can you define it? When two or more compounds having the same molecular formula but different structural formula due to the difference in the position of double bond, triple bond or functional group are known as positional isomers, and the phenomena is known as positional isomerism. Already I have said it. Alright, two or more compounds have same molecular formula. That is a common definition. Molecular formula will be same, structural formula will be different. How it is going to differ? In the first one we have seen in terms of chain, main chain, it is going to differ. Alright, in the main chain, remember it, that particular word. In the straight chain or what you can say, the primary chain, we can say that. In positional isomerism, the position of the double bond, triple bond or functional group is going to differ. Now how? See here. For example, I am having a compound, this 2. See, CH3, CH2, here it is CH, here it is CH2. Here also same thing, CH3, CH, CH and CH3. How many carbon, hydrogen, oxygen, how many carbon, hydrogen we are having it here? Count it. 2, 3, 4 carbon, 4 carbon. How many hydrogen? 3 to 5, 1, 6 to 8, 8. So C4H8. Now here also same thing you see, C4, H8, 3, 4, 4, 1, 5, 5, 3, 8. C4H8. So what is differing in these two compounds? The position of double bond. The first one is in the first carbon atom. In the first you can see. And in the second one in the second carbon atom. You will say, sir, I will count from here. Okay, 1, 2, same thing. Double bond is in the second carbon atom. And here it is in the first carbon atom. So what is the IUPAC name? It will be but1in, and this will be your but2in. So but1in and but2in are what isomers? Positional isomers, because the position of the double bond is different. That's it. Otherwise, they have got the same molecular formula. You can see the structural formula is different. How it is different? On the basis of its position. Okay, I'll give you one more example. You can see one more example. Now let us take here the compound here OH, and here one more I can give it. The compound here. Yes, I'll take here OH. Let us see. Okay, we can have more than 2 also we can have it. Yes, one more we can also have. Why not? One more we can have. 1, 2, 3, 4, 5. Here also OH. So I'm not putting the hydrogen. I think you will be able to understand it. Alright, you will be able to understand. Here you can see 1, 2, 3, 4, 5. Because numbering is the most important here. The numbering, the position is the most important. Here in the second carbon atom you are having OH. Here in the third carbon atom you are having OH. Here in the first carbon atom you are having OH. So what is the name of this compound? Name of this compound is pentan 3-ol. This is pentan 2-ol, and this is pentan 1-ol. You can also say pentanol. Better to write 1 because we are specifying the position. So pentan 1-ol. You can say that. So what is differing here? The position of the functional group is different. Alright, I am not putting hydrogen. Don't think this is the actual formula. You will be putting hydrogen definitely. But here hydrogen is not. In these examples, as I am showing you the examples, hence I have not put hydrogen. Otherwise, if you are writing the structure in your exams or in your notebook, you need to put the hydrogen. Understood? Don't think that this is the answer. No, that also I am making it clear. So in this way, what you find is that here what is differing? The position of the functional group is differing. Position of the functional group is differing. You can see third position, this is second position, this is first position. Otherwise, they have the same molecular formula but different structural formula. The basis of its position of the functional group. So when the position of the double bond, triple bond or the functional group it differs, then what is that known as? This is called as positional isomers. So positional isomers, what you find is that in case of chain isomers, you have seen it, the chain was different. So they are having different physical properties. Now physical properties means what? Means they will have different boiling point. They will have, if it is a solid, they will have different melting point. They will have different solubilities. They will have different densities. They will have different action towards that of light. We can say that when the light will fall, if the compound is optical, then the difference will be there on the basis of the light. On the basis of the light only, they will have different refractive index. So these are called as the physical properties. These are known as the physical properties. We can say that. Clear? So here also same thing. The physical properties is different because the compound is the same. All are alcohol. I have given you. In the previous one, all were alkenes. Now, not only aliphatic compounds shows position isomerism, aromatic compounds also shows position isomerism. How? See, Cl, first and second. It can also be written in the first and third. It can also be written in the first and fourth. It can be written in the first and fourth position. Is right? So what is this compound is known as 1,2-dichlorobenzene. 1,2-dichlorobenzene. The first and the second carbon atom, you can see that. Now 1, 2, 3. So this is what it's known as 1,3-dichlorobenzene. Here 1, 2, 3, 4. So it is 1,4-dichlorobenzene. So ultimately it is dichlorobenzene is common. What is differing? The number is differing. The position is differing. 1, 2, 1, 3, 1, 4. The molecular formula is the same. Molecular formula is it changing? No, not at all. It is not changing at all. The molecular formula. The molecular formula will be how much? C6. 6 carbon atom is there. Then if it is benzene, C6H6. But I have removed 2 hydrogen and in place of that I have put 2 chlorine. So it will be C6H4Cl2. Got it? It should be C6H6 if it is benzene. But it's not benzene. It is 1,2-dichlorobenzene. So I need to remove 2 hydrogen and in place of that I need to put 2 chlorine. So hence it is C6H4Cl2. So all these, whether it is 1,2-dichloro or 1,3-dichloro or 1,4-dichlorobenzene, all they have the same molecular formula, this one, but the structural formula is differing on the basis of the different position. You can also say this one 1,2 as ortho, 1,3 as meta and 1,4 as para. You can also say that. Clear? So in this way you can see position isomerism you can found in aromatic compounds also. You can find position isomerism. Next we will come to functional isomerism. Now what is functional isomerism? When two or more compounds, let me write first, functional isomerism. When 2 or more compounds having the same molecular formula but different structural formula on the basis of the difference in their functional group. When 2 or more compounds having the same molecular formula but different structural formula on the basis of how the structural formula will differ on the basis of the difference in their functional group, they are known as functional isomers. Now before starting the functional isomers, let me tell you, here not only the physical properties is going to differ but the chemical properties is also going to differ, because altogether when the functional group is going to change, altogether it is 2 different compounds. In the previous examples in the chain and positional isomerism, chemical properties is not differing, only the physical properties was differing. I have told you earlier. Got it? So what I said, molecular formula will be the same but the what you can say, the structural formula will be different on the basis of difference in their functional group. We can say that. Clear? On the difference in their functional group. Now, let me write one structure. Like here CH3, what more I can do? Put it CH2, then CH2, COOH. Alright? We will write the name later on. Now, we can also write it as in this way. We can also write, and after that we will count the carbon, hydrogen and oxygen and we will see whether we are correct or wrong. Now see, 1, 2, 3, 4 carbon, 1, 2, 3, 4 carbon, fine, 4 carbon. Hydrogen 3 to 5 to 7, 1, 8, 3 to 5, 3, 8, correct. Oxygen, 2 oxygen, here also 2 oxygen to C4, H8, sorry, O2. This is the molecular formula. See, molecular formula is the same for 2 compounds. Then what is differing? Differing is your functional group. This is a carboxylic acid and this is an ester. Wait. So how will you name it? This is nothing but butanoic acid. Butanoic acid. And what is this? Is an ester. So ester means alkyl alkaloid. You know the general name is alkyl means here methyl. Alkyl is your methyl. Alkyl alkaloid, na? Methyl 1, 2, 3. How many carbon? 3 carbon. Prop. So methyl propan OH. This is your OH. CO is your OH. Carbon carbon single bonds. It is N. So methyl propanoate. Alright. So these 2 compounds, they have got the same molecular formula, but what is differing? The structural formula is differing, you can see, because they have 2 different functional groups. We can have it. Clear? Now I'll give you one more example. one more example, you can see that we can have it. So many we can have examples. So many you can have it. Now suppose I am writing here, that is nothing but one more. See here, see here, CH3 CO CH3, and here it is, let us write it as CH3 CH2 CHO, and we can also write in this way, that is nothing but CH2 double bond CH, then CH2OH. Now let us count the carbon, hydrogen and C. Here how many carbon? 3 carbon. Here also 3, here also 3. Right, 3 carbon. Hydrogen 6, here also hydrogen is 6, here also hydrogen is 3, 1, 4 to 6. 6 hydrogen. Oxygen 1, oxygen here also 1, here also oxygen is 1. So C3 H6O. Alright, so you can see the 2 compounds are there, they have got 3 compounds are there, they have got the same molecular formula, but the structural formula is different. Let us name it and see what are the compounds. Now this is a ketone, so it is known as what? Acetone, or the IUPAC name is propan 2-one, or we can also name it as propanone, you know that. You can also name it as propanone, that is also correct. Because when it is propanone, one means second carbon atom only it will be there, it cannot be in the first carbon. Not got it? So it can also say propanone or propan 2-one, both are correct. Understood? Yes, and the common name is acetone. Now here it is aldehyde, al. So what is that? Propanal. Propanal. And here it is an unsaturated alcohol. Unsaturated. Because alcohols are all saturated. General formula of alcohol is what? ROH. R means alkyl group. Here it is not alkyl, it is allyl. Because what I have done, from propene I have removed one hydrogen. What is the formula of propene? CH3 CH double bond CH2. So what I said, CH3 CH double bond CH2. See, one hydrogen I have removed, and in place of that I have taken OH group. In place of that I have taken OH group. So when you remove one hydrogen from propene, what is that? It is known as allyl. It's a common name, of course. Allyl alcohol. Now if you ask me the IUPAC name, what is IUPAC name? IUPAC name is 1, I will count from here because OH is the main functional group. 1, 2, 3. So it will be prop. In the second carbon atom double bond, 2 in, and first carbon atom all. So prop 2 in, 1 all. We can say that. In this way, these are what? Functional isomers. You can see the compound having the same molecular formula, but they have different structural formula. We can say that. So when 2 or more compounds have got the same molecular formula but different structural formula on the basis of the functional group, then they are known as functional isomers. So here altogether all are having different chemical properties, because one is ketone, one is aldehyde, another is unsaturated alcohol. Definitely all they have different chemical properties. Not only the physical properties differs, but also the chemical properties differs. Alright, one more example I can give it to you, like CH3CN and CH3NC. Alright, CH3CN structure I have done it, CH3CN and CH3NC. This is what? That is methyl cyanide and methyl isocyanide, or we can say ethane nitrile, ethane 2 carbon, ethane nitrile, or you can say that is methyl carbylamine. We can say that. Clear? In this way, these two are what? You count it and see, they have got the same molecular formula, but the structural formula is different. On the basis of what? On the basis of functional group. This is nitrile, this is isonitrile. We can say that. So in this way, many more examples we can give it on the functional isomers. Okay? Okay, understood? Thank you very much.